The last topic we discussed today is beam design, more specifically that is prismatic beam design. Prismatic beam design. Previously, I think in elastic bending, we also learn how to design the beam with the bending moment, and now this class we take a holistic view to consider all the stresses, the stress due to the bending moment, stress due to the internal shear force, etc. So what are the processes needed to do the prismatic beam design? So at the study guide show you, the engineer normally they design the beam to resist the maximum internal bending moment. That's something we did before. So the chosen design after you design for the for resisting the maximum internal bending moment, that chosen design is then checked to ensure that it will not fail due to the transverse shear force. And since most of the beams are very long relative to their transverse dimension, they generally fail due to the flexural stress, which is caused by the internal bending moment, rather than the transverse shear stress, which is caused by the internal shear force. So the general design procedure for the prismatic beams is summarized in this table that I'm going to write down now. So make that table here with the step that we need to follow. The first with step here, so let's write down. And two things that we consider for each step. The first, for the beam, as you can see there, let's draw a simple beam in here. We have a beam, and if you have a pin, and we have a roller, and then we have a load applied, we have a distributed load, couple moment, distributed load, etc. W, P, couple. So it will create the internal bending moment and the shear force along the beam. So how can we design for that? So let's write down two things that we consider. The first is along the beam, and the second is on the cross section. On the cross section. On cross section. And the first step to design the beam is step number one, we have based on the design for internal bending moment. So it means that we design based on sigma actual, which is flexural stress, less than sigma allowable. So the normal stress due to the internal bending moment. So how can we design for this? We need to find out the maximum moment at the maximum moment. Okay, so from that, where we need to looking at is will be at the M max, moment max. And where to look at the moment max? Of course, we need to look at the from moment diagram. From moment. So go back to the lesson that we draw the moment shear and moment diagram. From that we can see where along the beam that we can find out the moment, maximum moment along the beam from the moment diagram. And the location at the cross section, which point, which location on cross section that we are looking at. So as you can see, the flexural stress due to the internal bending moment, it creates the maximum at outermost fiber. So with that, we have to determine at the outermost fiber. So at Y max. What is Y max? It means that at the outermost fiber. Okay, so here, what does that mean? At outermost fiber, beam fiber. So basically C. And after you choosing the beam, the size of the beam, whether it's standard shape or things like that, standard shape, go to appendix C, or the rectangle, find out the B and H, the thickness and the height, the width and the height for the beam. And then we can continue step number two, which is verify whether the beam can resist with the transverse shear stress. So verify. After we define, we need to verify the transverse shear stress, the actual tau is less than or equal to the allowable shear stress. And what we are looking at, of course, because this is a shear, so we're looking for the Vmax. The Vmax. And how we looking for the Vmax? Of course, from shear diagram. So as you can see from here, drawing shear and moment diagram is very important. The first step, as you can see, we need to draw the shear and moment diagram before we do on the design, because that helps us to determine where the maximum moment, where is the maximum shear that we can design with. And as you can see, for the reverse shear stress, the distribution is 0 at the outermost fiber and maximum at the neutral axis. So from that, it will be at the neutral axis when you do the check, the reverse shear stress. And then the last step, after you have all of that, you can apply the maximum shear stress theory. We apply the maximum shear stress theory. Number 3. Apply maximum shear stress theory. And that you can refer to the chapter 7, section 7.7 in your textbook, so that you can read more on that. So along the beam, which one? That is the critical combination of V and M, so shear and moment. So that one at the critical combination combo. That's right. Here, that's right. Critical combination of shear combination of shear and moment. So we look at the both moment and shear diagram, which are the critical that have both reasonable height on the shear and moment, and then we will check. And which point on the cross section that we are going to check for this scenarios, step number 3, it will be at for the standard shape like I or T shape, then add the web flange intersection. Okay, so that is the method to solve for a prismatic beam design, and we will apply this and show you more detail in worksheet 14D next.